Hello, so this is for Digital Diary 4 Organic Reactions and Mechanisms. I chose to work with Alkene 1 heptene. And so I went ahead and drew out all the isomers for this one. And I went ahead and tried to name them, and I'll explain why I named them and make any corrections in the process. And then at the end, I'll rank from increasing order of stability. I just want to let you know I will make a separate video explaining the mechanism. For mine, I'm supposed to react it with hydronium. And so let's get started with the explanation. So for the first one, I named it going from left to right because you have the double bond. Oh, sorry. I have the double bond here. And so I did 1, 2, 3. Oh, I actually want to choose a different color. 1, 2, 3, 4, 5, 6, 7. And then the double bond starts at the second carbon, so I called it 2-heptene. And then for if it's a Z or E configuration, I pay attention to, so basically the way I do it, I draw a line in the middle of the double bond, and I look on each side and I pay attention to what's connected to the carbon. And so in this case, we have a hydrogen and we have a methyl group. And so the methyl group should weigh more, it should have a higher atomic mass. So this one would have more priority. And then on the other side, you have CH2 and or a hydrogen, and of course it'll be CH2. And so from like other videos, I've learned that if it's on the same side, it will be Z. So you could say ZAME for Z. And so I already I tried putting the Z here. I have a hard time writing on this computer. So that's why I say the second part is going to be on paper or on my whiteboard. For the next part, I started from left to right. 1, 2, 3, 4, 5, 6. And so the longest chain consists of 6 carbons, so I call it hexene. And at the 4th carbon, there is a methyl group. So I named it 4-methyl-1-hexene. In this case, there will be, you have 2 of the same thing. There's a hydrogen on both sides. So I don't think for this one it would really apply, because you can't really figure out if it's Z or E if one side has the same molecule, if that makes sense. So I didn't really add anything for that one. And then the next one, oh wait, sorry, this one has, the second one I just did, this one has a CH group on the other side. And then for the next one, it's 1, 2, 3, 4, 5, oh, 6, 1, 2, 3, 4, 5. Oh, oops, I messed up. 1, 2, 3, 4, 5, 6. Oh no, I did fine, I think. So I named it hexene because the longest chain that I chose is 6. And then there's a methyl group that is on the second carbon, and then the second carbon starts off the double bond. Don't pay attention to the parentheses. I just did that to kind of separate it from anything that could make it confusing. Hopefully you can read it good. You know, if you have any questions, let me know. All right, and let me see. Yeah, in this case, these two are the same. So again, I can't really call it a Z or E. I don't think I can. Correct me if I'm wrong. But you got the two methyls and then you have a CH group. So when it comes down to ranking from increasing order, um, ranking it into increasing order of stability, you have to pay attention to the amount of substituents. And I always believed and understood that the more substituents, sorry, that is on the alkene or the double bond, the more stable it is. So choose a different color. I don't know. Let's do pink. For the first one, there is only two. I'm gonna write sub. For the first one, there's only two because that's what I circled here and here. For the second one, there's only one. All the other ones on the carbons are just hydrogens. Meanwhile, one of them is carbon with two hydrogens, so it's a little different. And then for the third one, we will have three. And then it'll be three sub. I just say sub for substituting. All right, and so in this case, increasing, we would say, I need space kind of, but it's okay. We're just gonna squeeze it somewhere. I would say, sorry, just thinking. So 2, no column. 2 is less than 1, and 1 is less than 3. And so 3 should be the most stable. But if I'm wrong, of course, just let me know. I would love to know if I'm wrong or not, because it could be reversed. It could be reversed. Okay, so let me see if there's anything else I should tell you guys. I don't think so. I think we're good. If not, I'll just correct it in the next video. But thank you for watching. Have a good day.